Okay, we're going to graph these two inequalities that you see here and then find the feasible solution, because these work a little differently than just when you have one inequality. So let's kind of write this bigger down here so you can see what I'm doing. My slope, remember we like to write the slope as a fraction if it's not. My y-intercept then is -1. My second equation, less than -3x plus 3. My slope is -3/1, and my y-intercept is 3. So that gives me everything that I need to see if I can graph this. Remember, it's not greater than or equal to or less than or equal to, so you need to use the dotted line. The first one, I'm going to go to -1. Now my slope says go up 6, 1, 2, 3, 4, 5, 6, and go over 1 and put a point. All right, I'm going to do my second line, which my y-intercept is at 3. And now from here it says go down 3, the -3, 1, 2, 3, and then go over 1. Okay, so the problem is where do I know where to shade? I mean, that's kind of the big issue. What you want to do is use what they call a test point. Okay, so a test point is if I'm here, does it work for both equations? Or if I'm here, or I'm sorry, inequalities, or if I'm here or here. And I know what you're asking, you're probably thinking, well, how do I know what test point to use? You should always use 0, 0 unless you have something set up greater than or equal to 0 or less than or equal to 0. Okay, so what that means is you plug in y equals 0, plug in x equals 0. I think 0 is greater than -1. Plug in y equals 0, plug in x equals 0. I think 0 is less than 3. So what that tells me, that 0, 0, which is probably hard to see, but is right here, that this is going to be my feasible area. And I check it, and it's fantastic.